Hi, this is Faxi Nadu, and welcome to another one of our videos for the Modular Crash Course. So up till now, in our course, most of the things that we've been doing is we've been showing how to make things that are very constructed, and oftentimes in the videos, we cloned various things. And in this one, I want to do something completely different. I want to talk a little bit about modular drones and noodle patches, and to show you how you can really freestyle with modular. And you don't always need to be thinking in such a rigid and constructed manner. So really how to take modular out of the box, even though it's already out of the box. So first of all, modular noodles or drones, as they may be called, are basically patches that if you look at this patch over here, there is no MIDI and there's nothing that is telling it when to start or stop producing its sound. It is always producing sound at all times, and it does have a MIDI clock inside. So in this one, I've chosen to. It has a certain bass timing, but you also don't need that. And many of the things happening in this patch are actually being, everything actually is constructed like live, like right now. This patch is like an algorithm that is being computed and sent to the output. So if we have a listen, and I know the sound of the team viewer is not that great, but this is kind of what it's doing. So what I'm trying to say and show is that modular can be really used to make soundscapes of many kinds. Um, you can make sounds and record them and then use them in your tracks. Doesn't matter actually what genre you're making, because you can bring them as audio channels, or you can use them as tracks in themselves if you're making soundtracks for movies, for computer games, or even as music, as ambient, chill out and ambient and drone music. It's a genre all by itself. So let's build something similar to this patch and use some of the same concepts used here, and I'll show you exactly how to do it. Um, and the first thing I want to say before we even start is that, again, we are freestyling right now. So we're going to be kind of just taking modules, attaching them, seeing what they do, listening to what they do. Of course, I kind of think it over in my head, and I kind of know what I am using and what it's going to do. But I don't know. I don't have no idea what it's going to sound like. It could sound like anything, and I'm just checking it out. And there are a million things you can do. You can use sequencers. You can use not use sequencers. It's really totally up to you. So let's start. What I have taken out over here is just so we can start real quickly. I have the multi effects, and there is no effects on it right now. A high pass filter that if you want to use to high pass the whole patch, and a DC filter that is always going to operate regardless of the other high pass. So we're going to get rid of the DC offset if there is any just by using this module. And then I took out a MIDI clock, which is divided to frequency, and a flexor ramp if we want to use flexor modules. So let's start out by, I don't know, let's go to gates, and let's see. We have here a random gate click. That's what I've used in that other patch. I think it's kind of cool. And what it does is it creates a random gate signal and a click at a certain frequency. And so we can use the gate to drive envelopes, and we can use the click to drive something like a comb filter or a resonating low pass filter or something that, needs some sort of click to get going. And let's add a comb filter and sound can do. And let's take out a constant frequency. Now you can do it anyway. You can put it on any frequency, but let's use multiples of 440, because like let's say you have the A440, which is the lowest A note. Everybody knows A440. So, and it's an easy division. If you want an octave less, we can put 220, 110, 55, whatever we want. So I don't know. Let's put this one on 440. And this will be our click. And we're going to need a mixer. Let's make 4 channels in this one. we'll have 4 different things going. So the click is going to go into the comb filter. And let's make sure we don't have too much of a high volume going on. Okay, and it's outputting some dirt. I don't know if you can actually hear it. Let's get a, there we go. So it's a really nice kind of corpus strong kind of sound. Now we've already got some cool random thing going. Really nice. And let's make this, let's just make it so it's dynamic and modulating and changing all the time. We can use various things, obviously. Let's just have fun. Let's take out this one, which I've shown in another patch. And this is a interpolated control sequencer. Let's just randomly put it on something. And now it's kind of moving it around. It's pretty cool. And how about we move it slowly over time? So let's just say real quickly that this would be one channel. And let's take out something else. Let's take out a sine oscillator. And you notice I'm putting everything on single mode. We have no MIDI going on here, so we have no polyphony going on here. So everything should be on single mode to kind of save some DSP. And I'm taking out another constant frequency, and let's do 220. I don't know. I'm just so it's an octave less than this one, even though this one's just a click. So whatever. Pitch modifier. Let's take options later on. So now this 220 hertz a signal is going into the pitch modifier, and this can be modified by an LFO or whatever we want. And let's use an LFO. Let's use one LFO here, and let's give it the option to get external timing. And let's see what this sounds like just as this. So without anything, it's just a sine, right? It's just a sine on 220 hertz. We can modulate it though with our LFO. So we already have some cool kind of alarm signal. And let's give it more modulation. Let's give it the we have our sine LFO over here. So let's put it right here. This will be like, this is the slowest possible setting on the scope. So this will be like our ultra slow LFO that we can use on various things in our patch. Now it's going to move it across the spectrum. So let's listen to them together. And maybe that is just a little bit overkill. There we go. Now, of course, when you're making noodle patches, what you want to do is like get a really big sound, right? So let's put a huge delay, huge reverb on this whole thing. So we have like a huge plate on it, on top of it. It's already making it much more interesting and deep. And we did not connect our high pass chain over here, so let's do it. Let's try an octave above. So I already got some interesting, I already have some interesting electronic sounds going on here. This is not bad. Let's put this much slower. 30 BPM. So it's already pretty interesting. And of course, like I said, we're noodling around, right? We're doing anything we want. We're not worrying about cloning anything or making anything that is even too logical. So let's just take, you do what you feel like doing, okay? I felt right here, right now, that this sound was overpowering and that this one, even though it was like on the loudest possible, it doesn't have enough grit. So I just feel like adding a distortion to it. And there are many options. And again, I'm just going to check out, let's see. Um, I don't know, what sounds cool? How about a germanium drive? And if you want to know what each one does, you can check it out. And let's get back our sound. Cool. So let's get some more stuff in there. So we have two channels and they're already interacting in a weird, dissonant, kind of strange and cool way. And let's add more to that. Let's take out a obvious thing that you can always use in Noodle patches is noise. So let's take out a noise generator. And I don't know, what do you want to do with it? How about a bandpass filter that is self-resonating? I just do this often. I'm going through the motions right here, but I'm just showing you around. So a noise generator through a bandpass, and if it's just like this, then it would sound like just like a noise sweep. And let's sweep it. And a little trick I want to do is, if you see right here, we have the sine. And so obviously a sine has a low point and a high point. And we've used the same sine in two places already. And let's have this same sign, but inverted. And inverted means it just flips the polarity of the sign. So when this module is, the output of this sign is at the top peak, the output of this module would be the same sign, but exactly the opposite phase at the bottom peak. So just for a variation. And you can use the inverter first for these purposes. Now it's kind of really drowning really slowly, like a really slow whistling drown. We can get a cooler tone. I feel like doing two band passes, slightly different. Maybe have this one moving one tick over here. And again, it's all that filtering really softened it up. So I want to give it some grit. Let's take out, I don't know, smoky distortion. Let's see what this sounds like. There we go. So how about one more sine? And let's, what do you want to do with this sine? Let's see what I did over here. I want to show, because I had specific modules that I had here that I wanted to show. The gate logic you know already from before. Okay, yeah, we can use this one, I guess. Let's check out the, oops. Let's check out the random gate generator. And what it does, obviously, is it produces a random gate. So it's the same as this one, except this one is like produces also a click. But it's going to have different values than this one because it's also this one. They're both random and in a different way, obviously. So they're going to output different values. And let's do what we did before with the with this oscillator, pretty much similar, but let's modulate it like in a different way. Let's take out a random, I'm just showing you all, there's so many ways to do these same things, but just going through some modules. So a random signal generator, and that can output steps, and let's kind of smooth these, have the ability to smooth these steps. Let's see what this sounds like. So where's the output? Here. Let's there we go. And let's give this some change too. And let's make it slower. There we go. This is kind of what I wanted. So it's noodling on and on and on and on and on and on. Oh, and we haven't even used this guy. Okay, forget it. We don't need this guy. Now, just so we can have a look at, let's make it quiet. Now, just so we can have a look at a few more modules that we haven't seen, let's take out, there are different filter modules that are more interesting. Like you have the normal stuff that obviously you need, high pass, low pass, and different stuff. But there are also some very interesting filters. For example, valve filters, resonators, phase filter that acts kind of like a phaser. You seen here inside Sonic Chorus packs as well. But there was this one filter that is kind of neat, and it was the SH1 Destroy. And what it does is this is basically a sample, a bit crusher, a sample reducer. It doesn't reduce bits, it reduces the sample rate. But it works like a filter does work, and actually has a resonance knob, and the sweeping of the sample rate is very smooth, very interpolated between the values. So let's have that. Let's move that around just a tiny bit. Maybe with the, there we go. And let's also have one look at one last thing. And I did it also in that patch. And look here, there's some of the filters here are stereo filters. I think this one maybe, yeah. And also let's take out a, was it in the special mono to stereo comb? And let's shove our whole patch out of these. Let's go crazy. So let's go, you know what, let's do this. So this is like all our channels are over here on the, where is it? On the mixer. And let's have them go into the high pass. Let's saturate them a little bit. Give them some more oomph. And then let's go into, let's try out this chorus. And it's cool because there's a dry wet. If we don't like it, we can just put it on dry. And the same with this, sorry, the comb, and then to the chorus. And the chorus also has a dry, both the comb and the chorus. So Let's see what we get here. And we get nothing because everything is closed. So I'm gonna modulate this as well, and I'm gonna use the same LFO. I'm gonna take a diode and put it on this position, and then the negative values will be turned into positive. So what it does is it's this LFO but twice as fast, basically. So just another variation using the same module. So and let's bring in all our sounds. So we have this one. And if I turn on my other patch, right, we have this, I have two patches going here. So I had this one as well. So what you can actually do is you can plan it out, not like fast right here like I did now. You can plan exact channels. Like let's say if you look back to the video where we made the drum machine, and so you can make you can load up 3 patches. One of them would be like the drum machine, and it would be on your BPM, and then you could load 2 more that are like this, like noodle patches, and you can have obviously way more than 4 in each one. You can make 8 channels of different things that harmonize and kind of work together well. I'm just giving an example, right? Like on each patch, and then connect all these knobs and whatever other knobs you want. Like get a really good MIDI controller, like a Behringer BCR or something like that with a lot of knobs, and then route all of these mixers into those knobs, and all of these mixers over here into those knobs, and the drum machine drum channels into those knobs. And you could actually really make a really cool on-the-spot live ambient performance using just the modular and these channels that you built, these kind of insane and mad channels that you built. So actually you could look at it as an example for algorithmic composition. I mean, it's not, you haven't inputted the algorithm in any like mathematical sort of way, but the bottom line, the output of this whole patch is you can see it as sort of an algorithm. So let's have this one. Let's bring in this one. Of course, you got to be careful what you're doing and know your channels. So the possibilities are obviously endless, and if you actually make some of these and integrate them with some other gear in your show, then yeah, you can make really crazy things. That's what I've shown you right here is basically what I've done in one of my when I performed live once in a kind of a drone and ambient and like experimental music festival in Augsburg in Germany. Then this is basically what I did. I brought the scopes in, and I had this really huge patch with tons of stuff going on. And just like I just explained, and I had my mixers on a controller, and I had other things going on out of here, and I had also pre-made drones that I triggered using a wave player, and I ended up with all these layers on top of each other and with some external stuff that I was using as well. So I had a ton of layers to play with, and the show was just 1 hour, and I was just mixing my signals in and out, and kind of playing with some filter cutoffs and with some pitch modifiers and stuff like that, LFO speeds. And the music is really dynamic and evolving, really psychedelic. I don't know if everyone will call it music, but to my ears, it's music. It tells a story, and if you plan it well, it can be really nice. And it can even be really nice even if you don't plan it well. So that was a little bit about Noodles, and the thing I want you to take from this segment is to just use your imagination, just make crazy connections and see what it sounds like. The worst thing that could happen is that you won't like it and delete the connection and do something else. There's no right and wrong per se with this stuff, but obviously the more experienced you are, then the more you can make neat things and kind of know what you're doing. So I'll see you in the next video. Have a good one for now.